Welcome to Made Up of Wires. We are decompiling Castlevania Symphony of the Night. I'm going to get my workspace set up and then we will get going. Alright, so Castlevania Symphony of the Night was a game for the PlayStation 1, PSP, Xbox 360. It's been ported to the PlayStation 4, among others. We're in the process of trying to decompile it, so we want to get back to original source code so that we can study the game, modify the game, learn about how it was built, and just have fun in the process, learning more about a great game. If you want to know more about the Decomp project, you can go to SOTN.z.dev, where there's progress for the project. We're working on a select set of objects that were on the original game disk, and as those are getting closer to completion, our progress goes up. So the main game engine is most of the way done. The Richter program is completed. We've been working on weapons, and we're going to continue that today. We have two more that are duplicates that I think we should be able to get through. I was a little nervous about the remaining two duplicates today, but I looked at them before the stream, and I think they should be fine. Normally I don't look at what I'm going to decompile before the stream, but I had a bad feeling about it, and it seems like it was unjustified. Hopefully that's correct. So decompiling is taking the code that was, or taking the objects that were originally on the game disk, splitting them into their various parts, so assets, sounds, code, data. The code that's on the disk is in a machine language that isn't easily readable by humans, so there's tools like Splat64 which will take that machine code, convert it to assembly. That's still not very easily readable by humans. So then there's other tools to automate the decompilation into C, which is readable by more humans. And then as people working on the project, we take that partially decompiled C and get it to match exactly the assembly that was extracted from the game. And once we have that, we can rebuild the original, rebuild game objects that look exactly like they were and are perfect matches for what was shipped on the game. This isn't the original source code from the game, but it's something close enough that other people can build on it. And so we're primarily looking at the PlayStation version on this stream lately. We probably will get into some PSP stuff in a couple weeks as well. So what do we find to work on? I've been using, there's a list in the project of duplicates. We have a few functions, 27 functions remaining in the weapon object. Let me find that. And so we're going to focus on the duplicates to get two more done today, and then we will go from there. So there's a list that's to find duplicates. We compare the assembly language that's extracted from each of the functions minus some address offsets to other functions that are in the project, in the game. And the only ones for functions we have left are these two remaining matching functions, which are part of Masamune and Muramasa. Like I said, I normally don't pull these up beforehand, and I need to look up the weapons and everything during the stream, but for whatever reason I had a bad feeling about how this was going to go. Alright, so let's take a look at the assembly that we're going to be decompiling. I'm going to choose 53, which is Masamune. And so we can look at that assembly and it's relatively short, and among the shorter of the remaining functions. And there is a little bit of complexity here, but not a ton. We can look at the C file as well. And see where this is going to slot in. So we already have the weapon entity attack for this weapon, and really we're just looking at this last include ASM line. And when this is in place, Masamune should be complete, I believe. Oh no, we have one more. Okay, so there's two still in Masamune. If we look at the Masamune effects as well, there's some really beautiful effects that come off the Masamune, which were certainly toned down for the Saturn. It'll be interesting as Saturn is decompiled, what that function looks like in comparison. The PlayStation version is significantly nicer. And the Muramasa looks relatively similar, except red instead of a lot of the rainbow colors that the Masamune has. Alright, so we are going to take that assembly and use decomp.me to start our decompile. Decomp.me is a collaborative decompilation editor. Off screen, I am copying this, and then we'll go to decomp.me, start decompiling, choosing PlayStation, Castlevania Symphony of the Night, and we'll paste in our function that we're going to be working on. The context is different function signatures and structs and other type definitions that will be helpful. It works like a header file in C. And so decomp.me is going to do a first pass decompile, and it can't figure out some of the types. And I actually think one of the types we don't have defined yet, and we're going to have to define that over the course of decompiling this. So that's one of the reasons we don't decompile yet. But there are some other things that we'll need to fix up before we get to any compilation. So this was an automated decompilation. The decompiler couldn't figure out all the types. So in place of those, it put question marks. And when it puts question marks, that's something we need to resolve before we can get to any compilation at all. To get started, I'd like to get rid of warnings. So I enable no built-ins. Other people remove these functions from the context. I haven't decided yet what I think the right answer is for that. The GCC, which is our compiler, provides built-in functions for memcopy and a bunch of other things. Sometimes we use that directly in the code by using underscore built-in underscore memcopy. But the libc for the PlayStation also includes those functions, and the types for those two different functions, the GCC version versus the SDK function, are different, and they conflict, and that's the warning that the compiler is giving. So everything in the context is fine now, but we still have some types that we don't know what they are. So we're going to go look through this code and try to determine what they are. The first one is this reference. When we see a reference plus some value multiplied by a constant, we can assume, initially at least, that this is an array, and the array is of, each element of the array is of size 2 or 2 bytes, 16 bits. So I'm going to assume that this is some kind of 16-bit. It might be signed, it might be unsigned. We'll figure that out. The next one is this B0, and this is used on the opposite side of this condition, and it's going to be the same thing. And then this is the one that is going to be a little bit of fun during this stream. This one is multiplied by a size of hex E, which is 15 bytes. I went through the structs that we have previously defined, or that others have previously defined. There's nothing annotated with a comment saying that it's size E. Size E is a relatively strange size because it's not a power of 2 or a multiple of 4, which is a power of 2. And looking at what some of those fields did, and we'll go through real quick and see what those fields are doing, I didn't see anything that lined up either. So I think we're going to have to define a new struct to fit this particular array. And we could go look at the content of that array as well and see if we can infer anything from the data there. Let's do that. So we know this is every 15 bytes. We're going to go over to the terminal and we'll see how this data looks. So assembly, data, and code is extracted into the ASM directory. We're looking at the US version of the game. And we'll look through, we'll look at data, and this is data for weapon 53. And actually, there was only one file there, so I can just open that file. So looking at how this data is broken up, so 15 bytes, we have 4, 8, 12, and then we are going to end right here as each entry into this structure. And then our next one is going to be 5, 9, 13, and we're going to end here. So this is kind of an odd, usually when structures are packed, they're packed on either word or byte boundaries, and so this is or 16-bit boundaries. So this is a little odd that this one is packed this way. We'll see if that's the case, but based on this offset in here, I'm fairly certain. I don't see anything very obvious in how that data is laid out initially. So we need to, we know what these types are now. I'm going to copy these into the context so the decompiler knows what they are. I'm going to get a fresh decompile before moving forward. And that may help resolve some of the types that it didn't know earlier, get us a little closer, but we still have this one that we don't know. So let's start defining a new structure. Before that, however, let's look at how this one is being used. So we're taking some element in this array, assigning it to temp3, and the decompiler didn't know what temp3 was. So we have a void pointer, which can't be used directly. It needs to be cast to something else. But we're going to figure out what the type is first, and then we will use it. So if we follow this type temp3, we're accessing an offset 0, and based on a condition of that offset 0, we're setting the U fields of this primitive one way or another. Then we're looking at an offset 2, so that's 16 bits in or 2 bytes in, and then we're setting our V's of our primitive based on that. So something, my guess is that this 0 and 2 are both 16-bit values. Whether they're signed or not is not clear yet. And then we're pulling out values at offset A, B, and C. Because those are each one off from one another, those are going to be byte values, so 8 bits. And that looks like red, blue, and green color values. And then at offset 8, the decompiler knows that this is a 16-bit value, we have a rotation. The timer here is also known as the weapon's lifetime, and we're pulling that weapon lifetime directly from the value at offset 6, so that's likely some type of lifetime or timer. And then we have the last field down here, which is of unknown 4, or offset 4, which is another condition which chooses one of these arrays that we identified earlier, one way or the other. And I chose signed values. The decompiler is telling me that these are unsigned values. I'm going to go and change those and run again. The closer I can get the decompiler to something that works before I get started, the less work that I have to do when decompiling. So I think we know in general what some of these fields are for. We don't know everything. So let's see if... oh, I was wrong. It's not offset. It's not a 15 byte. It's a 14 byte struct. That's okay. So we're going to create a new struct. We'll give it a name. We'll call this unknown weapon 53, but it's also going to be used in weapon 56. So our unknown, our offset 0 and offset 2 are going to be 16-bit. And does it tell us the type? No. So I'm going to say they're signed 16-bit, and we'll call this just the U flag. I don't know what it's for yet. Another one for V flag, and we can mark the offsets along the way. So our offset at 4 was down here. Again, it's an unknown flag based on the color lookup table, or for deciding the color lookup table. And then 6 was our timer or lifetime. Eight was our Z rotation. And then A, B, and C were RGB. So everything that I said earlier about not being aligned, ignore all that. So here we have an unused field for D. And our total size then is E. So now I think we know what the shape of this is. We'll paste that into the context and we'll get a new decompile. And the decompiler then was able to infer this type because it knows where the type was coming from. And we should see in here all the fields that were just named and just created. Those are now in place, and our decomp may be clean. Are we compiling? Still not compiling. That's okay. Line 32, we have an unknown 31 structure, so some offset at 31 of self. So this is going to be params offset by 8. shifted to the right. Params is at offset 30. So when this code is compiled, knowing that params is at offset 30, but we're shifting over by 8, the compiler knows I can just go up by 1 byte and grab the offset at 31, and it'll be the same thing. All right, so we're compiling now. We're at 80%, and we can go through and clean some other stuff up as well. And that will get us a little closer. Give me 1 second. So what I like to do next, as I'm decompiling, is go through and clean up these player access. So we have offsets into an entities array predefined as addresses in a symbol table, because we know that the player is always going to be the first element in an array that's at a fixed address on the PlayStation version. But the way that these are accessed in code is not through these global names directly to those addresses, but through accessing that array and then accessing the struct at that array. So this is a convenience just for the humans decompiling, but one that needs to be cleaned up. And then this player unknown is going to be the same thing. All right, so then GAPI is the same way. GAPI is a structure that contains, all of its fields contain pointers to functions. And we need to access that through the structure, not through those symbol names. All right, is there any other obvious things to start with? Eventually I'm going to, so the things that I will start doing for cleanup before really getting into the difficult parts are looking to see whether I can get rid of these go-tos. In this case, we're jumping to a block here that's just destroying an entity and returning, so those likely can be pasted in place. In this case, we're jumping to this block down here that's a missing else in this block. So I'm going to try to get rid of those and see if I can clean those up. And those went away nicely. It didn't help us in terms of getting closer to matching, but the code is easier to read. Next, I'm going to go through and look at the temporary variables and see if I can get rid of those, or how many of them I can get rid of. My guess is this temp S0 down here is going to be used in a similar way as it is up here, which is to get the current primitive and use it as a reference to that. And so these two can be combined into the same variable. They're never used overlapping, so we can reuse the same variable there and get rid of one. And we're going to call temp s0 prim. Likewise, down here we're using this temp v0 to get a primitive index that's being used down here. Let's see where it's being used. So it's being set as the prim index on our self entity, so we can get rid of this and use it directly. That took us a little further away, but that's okay. I think these things will shake out as we continue on. Temp s4, I'm going to rename that params. There is a _2. The way that these variables are named, they're if they're items that are used for calculated values, they'll get a temp name with a register. If they're used for fields that are used longer throughout the function, they'll be given a var name. Most of the time the temps can go away. Most of the time the vars can as well, but we'll see in this case. And then the S4, V0, things like that, A0, those are the registers that are being used. That temp s4 _2, that was being used as an x value. I'll keep it for now. I think it can probably just be done inline. And then S4 we're going to call params. So based on the hand that the weapon is in, we're going to be setting these values one way or the other, and let's see what those values are used for. So these are going to be used to set our V values, so we can call this V. And these are likely being used to set the U values. Oh no, they're not. This is being used for the color lookup table. Oops, not cut. If you have any questions along the way about why I'm naming things or why I'm taking certain things out or not other things, now where did I screw up? Now, along the way, I got rid of temp v0 and didn't pay attention to what it was being used for. This is the primitive index. And I'm not sure where that went, but we'll create a new one. Ah, I see. That's where that one went. This is Masamune, and the identical function exists in Muramasa. I'm actually going to rename this Alright, so let's keep going through the temporary variables. Aren't related to the item ID. So I'm probably not going to speak correctly about how weapon IDs and item IDs. Yes, the weapon IDs and the item IDs are separate. Several weapons can share the same weapon ID, but obviously they would have to be different item IDs to have different attributes. And when that item is created, often the params field. Yep. Thanks, Biz. So these, when they're inputs to the trigonometric functions, I like to call them angle. Oh, in this case, though, we might have a couple that we need to keep track of. So we can't reuse that variable. Actually, we may be able to. This line may be out of order. I'm going to hold off then on changing those. Let's go down to 139. Oh no. I hope I saved recently. Well, could Scratch be offline? Or decomp.me be offline? Bummer. Okay, so we'll have to take a pause for now. The other function that I did want to look at soon is there's one more mismatched function, and we could do this offline. This ST0, the duplicate finder, found that it's a 100% match. Whether or not that's completely true remains to be seen. I can't remember if I've looked at this one offline. I'll check back on decomp.me every once in a while to see if it's coming back up. But in the meantime, we can look at this one, and if it is a complete match, this can be done offline. So we will go to the terminal and we'll try to do this one. Shut all these down. Make sure that I have a clean environment. So, what might we do to match a function that likely has a lot of offsets? Oh, this one's actually extremely short, so I think I could probably do this one by hand. What I've done in the past for these is I'll strip the addresses out and then do a diff between the two functions at the assembly level. And actually, why am I getting the mad version if it has been decompiled? And then go through each of the addresses that are different and make sure that I have that variable declared. It is not decompiled in MAD. Bummer. So our duplicate finder, for some reason, did not realize that this was not decompiled in MAD. So I can't... Morning. We're having some difficulties. Decomp.me is down. So what else can we do in the meantime? We can migrate some data. That's always fun. So, let's find some data that has not been migrated over. And I think NO3 may be a good place to start. Let's see who still has data in. So STO has lots of, ST0 has lots of data, NZO, NO3 still has a good amount of data. Sen actually has a bit. I thought that was finished off. Let's look at center and see if we can finish that. So when data is being decompiled, sometimes we have to get it in the right structure. Sometimes we just have to make arrays of these values. In this case, all of these are known, and this file is actually pretty short, so it should go pretty quickly. Yeah, we could do that too. So Biz Murphy suggested tracking create entity factory calls. Decomp.me looks like it's back up. So maybe we'll go back to that then. One thing that I want to do, and I haven't walked through and set up a demo or something that I think would be interesting, was to go through a debugger and try to find what some of the unknown variables are doing. I think that's interesting as well. I spent a good amount of time in the prologue looking at the entities that are created when the vessels up in the attic are being destroyed. And it's pretty interesting how when you destroy some things, different entities are created for the explosions or the debris. All right, so we're going to go back to decompiling this, though, because I'm hoping that we can get through the rest of weapons relatively soon. I don't know where where this left us. I was looking at these angles and wasn't happy yet to change these names. My guess for many of these is that these lines are happening out of order. I think that's what I was going to look at. Are these lines happening out of order? And if we can reorder them, then we can reuse that variable. So yeah, that does match more closely. That doesn't mean that it's correct, but logically it makes more sense that similar values would be set next to each other. So having the X and Y values set before moving on to find new values logically makes sense. And a lot of times mismatches can be figured out by looking at what is what would be logical, what might you do as a programmer if you're going to be making those decisions. There was an interesting... So yesterday we didn't get to finish during the stream. This one, we should be able to get pretty close. I don't know if we'll finish, but there was an interesting case where... Oh no. Where a load wasn't happening. Oh, we're down again. Okay, maybe I'll go back to data and stick with it if Scratch is gonna, or decomp.me is gonna continue having problems. There's an interesting case where, and I'll pull that up. So yesterday was weapon 54. And let me see if I can find. It was going to this primitive index. So when the decompiler came through, it decompiled these two lines in the order where flags was being set after the primitive was being retrieved. But what was missing from the assembly, and maybe I still have that assembly, I cleaned. Perhaps not. No, I will have it here. And this was... Is this 08? No, not 08. Oh, it's entity weapon attack. Let's see, let's not wrap. Oops. Okay, so this seems innocuous, but on line 284 here, there was a load word for offset 64, and then we're doing this load word again at offset 64. And if we look at how this is being used, down here. Offset 64, hex 64 in entity is this primitive index. And so it makes sense that we're loading it here, and the assembly is saying we're going to load a -1, and then we're going to branch if the value that we just loaded from offset 64 is a -1. Otherwise, we're going to continue on. So then down below in our function, we're calling this, we're accessing this value again, the primitive index, but we just accessed it up here. And the compiler is smart. It says nothing changed between these two requests except for changing a local variable that's on the stack. So I don't need to load this value again from this offset because I already know it, and there's no way that it could have changed. And then I'm going to go through and do this flag setting stuff, which will change something later on. By reordering these lines, changing a field within this self pointer, at least at this stage of GCC is saying all bets are off. When you change flags at some pointer, I don't know that didn't affect the primitive index, even though those offsets are very different. And that forces GCC to say, I don't trust the value that I have cached of primitive index in a register anymore. I'm going to reload this. And that's what it did. So reordering those two lines was enough to add an additional instruction to reload that value, and everything else stayed the same. So that was kind of a fun thing to find. Good morning, everybody. It was a rough morning for me, up late, playing games. Rough because I made it rough on myself. Decomp.me is back again. We'll go back and see if we can make any progress there. So we were looking at this temp A0. It looks like we can now share this variable through all these cases. So I'm going to find all of these and call them inkle. And that helped actually quite a bit. Factory unknown 7E, I'm going to look that up. I can never remember if that's the one that is actually unknown. Where is factory? This is off of self, so we're looking at weapon. Yeah, 7E is unknown. We don't want to access this through the factory union, though. So every time we see self ext factory, that should be ext weapon. And that will likely cause some failures when this replacement happens. Oh, good. Likewise, the timer T would be better to call weapon lifetime. All right. Continuing on, weapon unknown 80 is unknown. There is a a comment in the entity header that suggests that this may be a Y value. I'm not going to take the time, though, right now to go through and try to figure out what that is. 0C is also unknown. All right, let's keep going through these temporary variables. Unfortunately, we might be blocked again. I'm going to copy this before decomp.me crashes. Oops, don't do that. And we'll see if we can get through this as well. We do have something that's compiling. So until decomp.me comes back, we can look and see what would happen if we took this non-compiling code and put it into the place where that assembly language is being included. 54, no. 54 is yesterday, this is 53. Oh, unfortunately I didn't grab the context before decomp.me fell over. So I would have to recreate some of it. We can try to do that quickly. Or we can go back to data. Let's see if I remember what these are. These are not in the right order. Let's see, we were size. The ones that I'm missing are lifetime and Z rotation. Okay. This one and then these two. unsigned. So while we're waiting for decomp.me to come back, I'm trying to get something that's going to compile locally, and we can look at how things are different. It looks like I replaced the wrong assembly file. Oh, what happened here? So I'm going to copy this all and fix my mistake. All right, so we're compiling. However, obviously this failed because we could tell from decomp.me that this hadn't matched yet, but the project will tell you that as well, and we're pretty far off still. So if we looked at the difference between our file that's being built and the other one, it's going to be pretty bad. Actually, it's not overly bad. A lot of times what will happen is there's extra instructions or instructions missing. Each instruction is 4 bytes. And so if you have one extra instruction, that will cause an offset that cascades for the rest of the file. And if you're just doing a diff of the bits, that will then cascade to basically the rest of the file. This isn't too bad. I look at this sometimes when I have minor errors, especially when trying to use a duplicated function. So this one is, when I get finished with this, the duplicated version is weapon 56. And weapon 56, is that right? Yes, 56. So I will take the code as it is and paste it over, and then look at the arrays, the various arrays that are being referenced, which is the only dynamic part of this function that should be different, and make sure that I correct those. Sometimes, though, there are constants that are different, and doing a diff like this will allow me to find that relatively quickly. I'm going to go back to decomp.me now that it's open, and let's keep going. Oh, it isn't. I'm going to, before it crashes again, oh, now it's back. Good. I'm going to grab these as well. And that way I have the ones that I know are correct in the right order. All right. Decomp.me is a really fantastic tool, and I've used Gahydra in the past with some maybe limited success, mostly just to understand how some code works, looking at the C that it produces. Sometimes for things that weren't originally even written in C, they were just written in assembly. I find it easier to follow the C. But I was never extremely comfortable in Gahydra, and decomp.me is nice and user-friendly. Being a Luddite, though, I hate online tools and browser-based tools, so it's times like this where it keeps crashing, and if I had a local version, I probably can run a local version. Maybe I should do that. Then you can't share, though. All right, so we're getting back. to where we were. So we have these var zeros here. We're going to replace that with you. Ah, man. Down here, var v0 underscore 2, that looks like we can reuse the color lookup table variable and make this a plus equals. Yeah, I do think that running it on a local server to cut out the point of failure probably makes sense. Alright, so then these var v zeros all appear to be just being assigned to X. I'm going to try to set those in line, and then we can get rid of that variable altogether. All of these. And that looks like it is converging. Mostly. This weapon lifetime, as long as, kind of as pointed out earlier, as long as self isn't being set, any of the fields aren't being set near the end here, this should be safe to use inline. Whether that's easier to read or not, we'll see. That actually got us relatively far back, so I'm going to undo that, and then 10 past 5 will become, we'll just call it lifetime. This particular field is effectively the remaining number of frames for the weapon. A few more left. So here I think we can reuse V. Oh no, we can't. Because in some cases it is has an extra 2-bit set, but that does work here. And these, this is going to be a one-liner, and actually I could rewrite that as a one-liner right away and avoid all this. So these are going to be set in line like this. And that may... So we still have a few more to get rid of. Temp v1. It's not used. Temp s6. So temp s6 is y. And then this primitive index 5, which got replaced when I replaced the other variable. This is unknown 7e. We're incrementing it and then looking at the, comparing the value. So that one goes away as well. So none of that got us really any closer to convergence, but it did clean up most of the extraneous variables. Temp s3. Oh, that's our structure that we don't have a name for yet. There is one stack variable that we're not accounting for, and I won't usually worry about those until I get closer, because sometimes they shake out. But we'll kind of go through the end and see if there's anything super obvious. So down on line 134, I'm not sure what the V suffix on the shift right arithmetic is doing. So I'm been meaning to make a, I have this really nice Motorola 68K chart. I was spending some time, maybe 2 years ago or so, working on a 68K emulator. And this chart was super helpful for writing the decoder. And I'd like something like this for MIPS, and I haven't seen anything quite the same, so I might spend some time doing that in the next couple weeks. Somewhere I think I have a MIPS. Doesn't everybody have a PDF of MIPS instructions open somewhere in a tab? Apparently I don't. So the only difference between SRA and SRIV looks like the value to be shifted by is coming from a register as opposed to coming from an immediate value. Does that look right? Yeah. So in our code, we're saying shift by the immediate value 8, so shift over by 8. Whereas the compiled code, that value is coming from a variable, and coincidentally, that variable is also the one that we're missing from the stack. And I can pull that 8 out into a variable, but I'm trying to determine why the compiler, if I set it to a constant 8, why the compiler won't just say, I know that that variable is 8, and I never change it. But we will try it and see. Let's see where that is loaded. So somewhere around line 103. a lot of the times when I'm talking through, I'm talking through my own internal model of what I think the compiler is doing. And yeah, like I thought, there's nothing dynamic about this value. The compiler knows that it's always going to be 8. So there must be something above where there's a possibility that this value is not 8. Otherwise, I'm not sure why that would be pulled up. Or there's some other cause that is not obvious to me. And I don't see that register being used elsewhere. Oh, how did I screw this up? Maybe this is my problem. Maybe I wasn't compiling the whole time anyway. No. Same thing. Oh, actually, of course. So not all of these were shifts by a variable, but did work. Some of them were hard-coded shifts. So for reasons that I'm not sure of yet, this last shift is coming from a variable. And that gets us really close. And actually the register fell out after that, after the other ones were fixed. So it looks like the end of this function is matching, which is good. Alright, so let's go back up to the top and work from the top down. So I kind of like to squeeze in through the middle. There's going to be some stuff in here. Likely these, so like the step, that's typically the last thing that gets done. And we can look at line 75, where that is. There's likely instructions out of order here. So some of this should start working out. So we're storing a 0. So these are probably out of order. Yep, that worked out. Moving up. That immediate value is fine. So looking at the offsets, so we're setting 3A, field 3A here, but in the original 3A is getting set earlier, and 3A is going to be this 20, is that right? And possibly this is being set earlier. And those go back. So it was the enemy ID that was out of order, and all those work out. So we're missing a store of a 16-bit value somewhere up here, and that's because priority is going to be out of order. And those fall in line. 45. So it's possible that these are out of order. It's also possible that they were written as one-liners. So in the original, we have a load immediate of C0 followed by 2 stores. It's almost as if this is being pulled out into a variable as well. Yeah, so I'm going to take these and I'm going to pull them out into a separate U variable and then see if I can do this assignment. Let's try 2 things. Let's move this up to a 1 line. And then do this assignment in line as well. And that worked out. So there is so my offsets are wrong. No. Which line is this? Oh, so I should be setting prime 0 or U0 first, and then U2. And now those match. Going up, line 25. This is going to be out of order. Now that works. We're getting close. So our stack is fine. Immediate values, which are offsets into structs, those are fine. Decomp.me doesn't know what those are, but the compiler will. There's going to be some macros that we need to use down here when this is finished. But this isn't where our... Oh, this is where our issue is. Alright, so... we're using the wrong registers. And we're doing some out of order math. Let's see. So changing that to an OR, which ultimately it can be because everything is shifted away, and maybe that's what the... I'm going to switch this to the macro version because the macro might clean this up. So this pattern for weapons is going to use a factory, and this is one of the things that Biz Murphy was mentioning before. This create entity from entity factory from entity. When it's using weapons, typically the hand of the weapon is used to modify what entity factory is going to be used. So we'll change this to factory. And the first argument to the factory macro is going to be this offset by 1. And then the second is going to be this 38, which I'll change to a constant later, and all that falls out. So the shifts are off. We'll change that to an... Nope, that one is correct. So it looks like this was being shifted. Oh, I'm not shifting enough. There we go. And then this, this 38 value is being ORed. Yeah, the macro, the macro already shifts this over, and then ORs with the second argument here. I'll take a look at that in a bit. That gets us at least the correct layout of the assembly. On line 89. Oh, yeah. Okay, so Biz Murphy's saying ORing against the factory instead. Did that work? No. Yeah, there's something funny here with the way that it's merging this this second argument that I haven't encountered yet. We'll come back to it. I'm not too concerned. All right, so we have some register differences down here that we need to right, so this is not a typical idiom for the factories. We can look at what those look like. Biz Murphy, I think, has done most of the work around this within weapons to begin with. So often, and typically, the first value to the factory is a constant. And that may be what is happening here, and I could try pulling that out, is that unknown 7e is an input to this first part that's being added. So it's pointed out that 42 may look a lot like what we're working on now. So let's take a look at that. Not OC though. Weapon 42? Maybe I'm missing it. Line 190. Oh, specifically the... Oh, interesting. Okay. So, yes, instead of using the factory, basically computing the value in line, let's try it and see. Got it. So, in this one, the constant's pulled out into this unknown variable to be able to do the addition. So we can reorder these statements as well and see if that changes how this might be done. But we'll use that as a template and go back to ours and see if we can slot that in. the way that it is. Normally I have my my font set on my terminal to something ridiculously small, and so I make it big, obviously, so people can read while I'm streaming, but I get so little context that it's hard for me to see the forest for the trees. All right, so we'll get this as close as possible. So here we're the factory macro would have shifted this first value by 8, and so we're going to shift it by 16. And we'll put our constant here. Look at that. Oh no, we're still not right. Oh, because we this is why you want Biz Murphy on your stream if you're doing live decompiling. He is like your static analyzer. Thank you again. All right, so we got through that. Now we have some register mismatch. Instead of all of the AI tools that can code for you, you get Biz Murphy in chat, and he'll do it for you. Biz Murphy, I want to decompile a SOTN weapon function, and then code comes out, and you submit it for a PR and take credit for all of his work. All right. So we have some register mismatch and some add instructions that are out of order, and so possibly if we fix these, the rest will fall out. So let's take this and reorder that. That's happening too early still. Those are fine. So we're missing this, or no, we have an extra load high for 7C. And that's coming from here. Sorry, it's not extra, it's out of order. Okay, that got a little closer. Oh, no, it didn't. So we're grabbing our X and Y. These X and Y values may be inlineable. Possibly not. This hitbox is suspicious because it doesn't have to do with the rest of this code down below. Can I pull that out? Does that change anything? It does not. It's still happening out of order. It is possible that these are inlined. We could try that. Nope, the compiler did not like that. So here we have a no-op on line 108. When branches are done, there is some instruction that's going to be executed. The instruction immediately after the branch is thank you for that suggestion as well. So let's get rid of all these casts. Which will clean it up and make it easier to read. The unsigned 16s as well. We do have, let's move this closer, which will match those a bit closer, but it doesn't change the order of the instructions. This lifetime I'm going to pull up as well, because it doesn't seem to have anything to do with this. It doesn't help us though. So we start on line 95 is where things start going south. With register misallocation, though, it's not always related to where the problem starts. I think it has to do with this this no-op that's missing. So here you want something that's going to be known to need to be calculated regardless of which direction the branch takes. Biz Murphy is suggesting to look at weapon 25. Yeah, okay, so this is a good point. So what is the difference between each of these? It's whether or not we're adding or subtracting this value. So are we, if we're facing left, we're going to subtract, otherwise we're going to add. And otherwise, this computation is the same. But the computation is happening twice. We are compiling it twice. And then this assignment, the assignment is only happening once. So I'm going to take up this value and put it in a local variable and see if that, and then do the assignment at the end and see if that can coax the compiler into and thinking back to how this was originally written, this is how the decompiler, we could look at it here as well, this is how the decompiler had decompiled this. And I put them in line, hoping for an optimization. that I didn't get. And we'll go through and do all these and oops. Come on. And are these otherwise the same? We're updating the angle each time, but otherwise, yes, they're the same. So now that that's further away. So I can it's this instruction that is out of order. Let me get rid of these sine 16 casts as well. Oh, that made it worse. That means lifetime is likely a sine 16, and I have it as a unsigned. That fixes that. Unfortunately, I'm running out of time in my schedule to continue doing this. But I will throw this into the permuter. And we can see what the permuter does. We're at 53. So again, we'll have a failed match, which is expected. So we found something a little better. We're going to have differences between what the permuter generates and our final function because of the same offset issue that decomp.me has. I will look at some of these. Oh, 105, that looks very promising. These are my least favorite, where it introduces a new variable. So while this does work, I don't like it. The interesting one is here, splitting the angle assignment with the addition, possibly. We'll let that keep running. I actually like that, now that I think about it. I'm going to change these to minus equals, and that will maybe shed some light on why that works. So if we set the angle to the rotation up here, And then some of these are sick. And then do the plus equals for each of these. Each of these blocks then has effectively the same structure. And then, so likely what is left then is these statements being out of order, which will... Oh, lifetime is being used down here. Helps in some ways, hurts in others. There we go. So that worked out. And then on line up on line 90, let's try to, where was our lookup table set initially? So lookup table is set up here. Let's try to put that assignment inline. There we go. So that was it. We got it. So I don't think I would have... this is one of those cases where even poking at the assembly for a while, I would not have thought to pull that addition out, or that addition would have changed the register allocation the way that it did. And sometimes those things are very non-obvious. We could look at the original decomp and see if M2C figured that out. And M2C did not either. So fortunately, in this case, there's a rule in the permuter to find that case, and it did, and that was what allowed us to crack that difference. So to show that this is a match, let's go back to the project, and we can shut down the permuter. Thank you, permuter. And 167. There we go. So we have a match. So we made it through this one. This one is, I believe, identical to 56 as well. So we will have another 2 weapons done, which will bring us to 25 weapons remaining after today. Getting even closer. We've gotten through over half the remaining weapons in just a little over a week, about 10 days. We got through 30 weapon functions in 10 days, which is amazing progress. And so with 25 left, I'm not going to say that the last 25 are going to be done in 10 days as well. There definitely is some complexity that is there. My time is up for today. If you want to know more about the Castlevania Symphony of the Night decompilation project, go to SOTN.z.dev. There you will find a link to the GitHub repo, where this code hopefully will be landing sometime later today after I clean up some things and get it ready for submission. And you can see the code from all of the previous streams that's been committed there as well as the work from many other great contributors who are doing some amazing work getting us back to source code that's available to the public for Symphony of the Night. There's a Discord server as well where we're talking about decompilation related to this and related to the version of the PlayStation SDK that was being used for this, the Xbox 360 version, which has a neat decompilation, mechanical decompilation that was done. The PSP version is helping us get back to source code as well. Lots of interesting things there. People working on mods, people working on sprite changes. And we'll be back tomorrow. Maybe more weapons, maybe something else. Maybe we'll look at going through a debugger and attributing meaning to some of the variables that we don't know yet what they're for, or some of the functions that we don't have good names for yet. Anyway, thanks for watching. If you want to see more, follow. I post these up on YouTube as well. If you need to go back and see anything, they'll be published here on Twitch later today as well. That's all, though. Thanks, everybody, and thanks, Biz Murphy, again, for your invaluable contribution. Adios.